In this video for section 2.6, we're going to do the solving exponential equations problem. So our first question is asking us to find the value of y that makes each equation true. And we're starting with 10 to the y equals 100. So what we need to find is the exponent that we would put on 10 to make it equal 100. And you might already know this, it's 2. So 10 to the second power, or 10 times 10 equals 100. That means that y equals 2. For part B, now we want to know 10 to what power equals 10,000. So there's a few ways you could do this. You can continue working up from your part A answer. So if 10 squared equals 100, if we multiply both sides by 10, we get 10 to the third is 1,000. And if we multiply by another 10, we get 10 to the fourth. 1,000 times 10 is 10,000. You might also remember a trick specifically for powers of 10 where you can count the zeros. So 10 squared equals 100. 100 has 2 zeros, and so that means it has a power of 2. 10,000 here has 4 zeros, so that means it's 10 to the fourth. So 10 to what power equals 10,000? That power is 4, so y equals 4. You can also do some guessing and checking on a calculator. Just do 10 to various powers until you get the right answer. That works too. For part C, now I want to know 10 to what power equals 100 million. So if I look at this, I could also keep working up here with the chart that I started earlier, 10 to the 5th, 10 to the 6th, until I got the right number. I can count the zeros. I see that there's 8 zeros here, so this is 10 to the 8th. Again, I could also do guess and check on the calculator as well. And for part D, 10 to the y equals 1. Now I can work backwards on my chart. So if I have 10 squared equals 100, going down a power of 10, 10 to the first is 10. So if I'm dividing by 10, and then if I divide by 10 again, I get 10 to the 0 equals 1, because 10 divided by 10 is 1. You might also remember from an earlier algebra class that anything to the 0 power is equal to 1. So not just 10 as the base, but any number raised to the power of 0 is 1. So however I want to think about it, I get an answer of y equals 0. Now, for question 2, we're approximating the value that makes each equation true to 2 decimal places. So we're not going to get nice whole numbers here. We're going to get a decimal approximation. And for this one, if it's 10 to the y equals 7, I can start by thinking about what 2 whole numbers it's going to be in between. So if I know that 10 to the 0 power equals 1, and 10 to the first equals 10, I know that 7 is between 1 and 10. So my power is going to be between 0 and 1. So let me get out my calculator here. We'll do some guessing and checking. A good place to start is probably going to be 0.5. So I'll make this small enough for you to see it. 10 to the 0.5 power, 3.16. Okay, that's not big enough. And then I can just change my decimal here to get closer to 7 for my answer. So 3.98. We can try 0.7. That's 5. We can try 0.8. Okay, I'm getting closer to 7, 6.3. 0.9 is too much because now I'm over 7. And we want 2 decimal places, so I'm going to add some decimal places here. Let's try 0.85. Oh, that's pretty close, 7.079. So now let's see if we can get closer than that if we go to 0.84. So that's 6.91. So looking at these two, deciding which one is closer to 7, it's going to be the top one because this is 8 hundredths away. This one is a little more than 8 hundredths away. They're actually pretty close. But 0.85 is going to be my closest approximation. So 10 to the 0.85 is approximately 7. So y approximately 0.85. Now, for part B, I could do the same process and repeat it using guessing and checking. Now I'm trying to get 70 instead of 7. So I know that this one is going to be between 1 and 2 because 10 squared is 100 and 70 is less than 100, but 70 is more than 10. Or I could use the same kind of process that we used up here with whole numbers. So I know that 10 to the 0.85 is about 70. If I add 1 to the exponent here, then I am multiplying the other side by 10. So this is one additional factor of 10. It's a little harder to think about when it's a decimal, but it's the same thing. So adding 1 to the exponent is multiplying by a factor of 10. So 10 to the 1.85 power is approximately 7 times 10, which is 70. So the answer is that y is approximately 1.85. Again, or you can do guess and check on the calculator, and if you do that, you can verify here that 10 to the 1.85 power is approximately 70, and again, that's as close as I'm going to be able to get if I am going 2 digits after the decimal point. So 1.85 is the closest to 70.